Okay, good morning, students. Welcome back to today class. So in today we will discuss the new topic of refrigeration, that is vapor absorption refrigeration system. In the previous class, we had discussed that is vapor compression refrigeration. In short, we'll call it as VCR. So as the name indicates, the second letter C stands for compression because we use one device, the major device, that is compressor. So we have used the compressor device, the compressor, the refrigerant undergoes compression. So that is the reason it is called VCR. But in today's topic, in the vapor absorption refrigeration, there will not be compressor. Okay. And here there will be one more, the device, one chamber will be used, that undergoes absorption process. That is absorber will be used. Absorber. Okay. So what we do first is we'll list the components. What are the major components in VAR? In short, we call it as VAR. In one of the video lecture, I have explained you the difference between VCR and VAR, and that video lecture will help you for some major topics and for the interview purpose also. Okay, first component what I do is we'll condense evaporator. We'll take it as evaporator. Evaporator is also called as cabin. Okay, so we have to place an evaporator where we need to cool the system. For example, you are going to reduce the temperature of any system, where you need to install that is cabin, because the refrigeration is a process of reducing the temperature of the system. So first part is evaporator, or it is also called as cabin. Second, what you will take it as absorber. Here absorber is a second component or second device you can use. The absorber will take one solution. Here I will take water solution. Water as a solution, as a liquid. Okay. And dear students, we have to choose the solution in the absorber in such a way that the refrigerant, what you are using in the refrigeration cycle, that refrigerant should mix with this solution easily. Okay, and we can separate easily also. It should be soluble in the refrigerant with solution, and we can separate easily. Such type of liquid we can use in the absorber. Okay, for example, in the vapor absorption refrigeration, the refrigerant is used is, let me take a different color chalk please. The refrigerant used in the vapor absorption system is, that is ammonia. We'll be using ammonia as a refrigerant. Let me write. Yes. In the vapor absorption system, we are using ammonia as a refrigerant. Okay. And in the absorber, water as a solution. So vapor absorption refrigeration is also called ammonia water absorption refrigeration system. That is also called ammonia water refrigeration system, which is also called as ammonia water refrigeration system. Okay, you keep in mind. Okay, the another name of vapor absorption system is ammonia water refrigeration system. And the third component, what I will take here, it is heats up, or we can use pump. I will explain you why the pump is used here. And fourth component we will use as heat source. Okay, heat source, or we can call it a generator. Generator is not nothing but this is used for generating electricity. This generator, why they kept generator is it will increase the temperature, and as well as it will convert liquid to vapor. It is generating the vapor, so it is called generator here. Okay, just like in boiler. Okay, don't assume that generator is a what we use in the normal store centers and which is used for generating electricity. No, that is not generator. Here this generator is nothing but it is used for generating vapor. Okay, or here we are using heating coil as a heat source. Heating coil. Okay, fifth one is condenser. Condenser, and the last sixth point is, that is expansion valve. Expansion valve, or we can call it a throttling valve. Okay. Now, so what is the difference here in the VCR and VAR here is, in place of in the VCR, here what we used in the absorber, pump and heat source. In place of these three devices, we have used compressor there. In the VCR system, there was no absorber, there was no pump, and there was no heat source or generator or heating coil. So in place of these two, three, four component, we have used compressor. Okay, keep in mind. Anyway, I have explained you in the one of the video lecture in the difference between refrigeration of VCR and VAR. Okay, please watch that video to understand the major difference between these two. So these are the 6 major components which will be used in vapor absorption system. Okay, so one point you need to remember here is, so what I do is I will draw one block diagram, a simple diagram to understand all these components. Okay, let me go to next page. Okay, this is a simple block diagram of the VAR, that is vapor compression refrigeration system. Not a compression, here it is absorption system, vapor absorption refrigeration. The first one is evaporator. Okay, and this is also called as cabin. You remember, it is also called as cabin. Okay, and this point I will call it as point number 1. I will take this as 1 point, beginning of the process, beginning of the cycle. And dear students, as I told you, the refrigerant used in the cycle is ammonia, and in the absorber you are using solution aqua ammonia solution because it is mixed with water. Okay, solution is aqua ammonia solution, and here we are taking some solution here that I will explain. Don't worry about that. The first point is evaporator. At the inlet to the evaporator, the condition of the refrigerant is in liquid state. So I will call it as LR. Liquid, LR stands for liquid refrigerant. Liquid refrigerant. This is the condition phase, and it is at low temperature, LT, low temperature, and as well as low pressure. These are the 3 thermodynamic properties we need to. So I will explain now. Point number 1 is inlet to the evaporator. At inlet to the evaporator or cabin, the condition of the refrigerant is in liquid state. Liquid refrigerant at low temperature, low pressure enters into the evaporator. And in this refrigerant, what this refrigerant will do is it will absorb heat from the entire evaporator. And this evaporator is placed inside the cabin. It absorbs all the heat from the cabin and it becomes in the vapor state. Now the condition of the refrigerant is in vapor state, vapor refrigerant. And during the process 1 to 2, the temperature will be remain same, that is at low temperature, and the pressure is also same. So here I will write 1 to 2 process, it is at constant temperature process, constant temperature and pressure. So when there is a temperature is constant at inlet, low temperature and low pressure, so what type of heat it has absorbed by the refrigerant is, the refrigerant has absorbed latent heat. Keep in mind. Please remember this word, latent heat. In the interviews, they may ask you, in the evaporator of vapor absorption refrigeration, the liquid refrigerant is converted to vapor refrigerant. There is a change of phase from liquid to vapor. So when there is a change of phase of the refrigerant, so it has absorbed latent heat. When latent heat is absorbed, the temperature is of the refrigerant is constant. Now here, please look at the word, what they have written here. Ammonia vapor they have written here. Ammonia vapor, now it is in liquid, the vapor refrigerant condition. Next, this ammonia vapor, that is vapor refrigerant at low temperature and low pressure, enters inside the absorber. Okay, now you can ask a question, why they are using absorber here? Why they are not using compressor directly? And dear students, keep in mind always the amount of energy or the power, the energy or the power required for pumping the vapor substance. It may be vapor ammonia, it may be vapor, any steam or any gases. If you are pumping the gases from one place to another place, the amount of power what you required is more. because the volume of the gas is more. So you need to compress it first, or else we need to mix with any other solution. And one more point you need to remember here is, as the temperature of the gases increases, the viscosity decreases. So we need more energy to pump the ammonia vapor from evaporator to the condenser. So it is the reason what they do is they will mix this evaporator refrigerant with ammonia solution. Whatever the refrigerant it is coming from the evaporator, that refrigerant is in vapor state. That vapor refrigerant will mix with absorber solution. Here we will take some water solution. Okay. So when the ammonia vapor mix with water, it will become a solution. Okay. Now that is called as aqua ammonia solution. Okay. That solution now it is in liquid state. Vapor and liquid. Vapor is a refrigerant, liquid is water. So now it will be easy to pump from one place to another place. So we will pump using the pump device. So using the pump, we are supplying the absorber solution from the absorber to the generator. So here in the generator, they will be using one heating coil. Now, what is the use of this device heating coil is, they will increase the temperature of this vapor. So the high vapor will go to the ammonia vapor as a solution. And now we can see here, ammonia vapor enters into the absorber. It will mix with the solution, that is water solution, that will be pumped and generated here. Now we need to separate the water is one side and the vapor another side. Now, because we have taken from evaporator to the generator directly with the help of pump. Now we have to separate the vapor one side and the liquid other side. So that liquid is going back to the absorber here through this solution. That is the reason it is called as weak solution. Why it is called as weak solution means the liquid and the vapor has got separated. The vapor is going this side and the liquid is coming back to the absorber. You can ask a question, so what is the use of mixing in the absorber and again separating in the generator? This is a simple question, it may arise in your mind. But we cannot pump the vapor phase ammonia from the evaporator to the condenser using the help of pump. Even you can pump, but it requires more energy, more power you require. For example, efficiency of or the performance of this VCR is 50%. Just an example, 50%. 50 rupees is the profit for you, and you are spending more energy. 100 rupees you are sending the pump. So it should not be used. It is useful, unuseful. Correct. That is the reason if they mix the ammonia solution with water, then the amount of energy what you required for pumping the refrigerant from absorber to the generator is less. That is the reason, simple reason they are using generator. And with the help of heating coil, the vapor temperature is they are increased. For example, this vapor is in saturated, they'll make it superated so that the liquid and the vapor get separated easily. That is the mean. Next, this ammonia vapor enters into the condenser. Now you can say that this is at high temperature, vapor refrigerant and high pressure refrigerant, because you have used the pump. With the help of pump, the pressure increases. Okay, so that is the reason here is a low pressure refrigerant will become high pressure, and low temperature will become high temperature because of heating coil. And here is a vapor refrigerant, here is also vapor. So there is no change in the phase, only temperature changes. Okay, now what is the input to the condenser? At the input, high pressure, high temperature vapor refrigerant enters inside the condenser. What is the use of the condenser is to reject heat to the surrounding. Whatever the heat it has absorbed in the evaporator, that heat it has to reject. Okay, because it is in vapor form, it has to come back to its liquid form. So any vapor come back to liquid, obviously you have to reject the heat. So what type of heat is rejected in the condenser is latent heat. So when any substance absorbs latent heat or rejects the latent heat, there must be change of phase. So here vapor refrigerant, now it converted to liquid refrigerant. Liquid ammonia. Refrigerant used inside the cycle is ammonia. So that is the reason ammonia liquid. So here latent heat is rejected. So this ammonia liquid now at the outlet of the condenser. Outlet of the condenser is what? Low temperature, because high temperature is rejecting heat to the surrounding. Okay. Sometimes it will be at high temperature, okay, high pressure. But what is the condition? It is at liquid refrigerant. So this high temperature, high pressure liquid refrigerant enters in the expansion valve. Where is the expansion valve? Here is the expansion valve. And this is an intermediate, just like a receiving. It is receiving from the condenser. That is called as receiver. So this high pressure, high temperature liquid refrigerant now enters inside the expansion valve. When it enters in the expansion valve, here is the expansion valve. Okay. And when this high pressure, high temperature liquid refrigerant enters in the expansion valve, it will become low pressure and low temperature to liquid refrigerant. That is the input condition for the evaporator. Understood? So this is how it completes the cycle. Okay, I will explain in briefly again in 2 minutes. Let me take in another simple sketch here. One more sketch. First, you need to understand here is what is the condition of the refrigerant at input to the evaporator. And for what is called so low pressure, low temperature, liquid refrigerant. What is the type of refrigerant you are using in the this vapor absorption system? We are using ammonia. Ammonia as a refrigerant. And what is the solution you are using in the absorber? Water solution. Keep in mind. This is the two major points. Next, this is a condition at the inlet to the evaporator. Point number 1, beginning of the process. So low pressure, low temperature liquid refrigerant enters the evaporator, and this refrigerant absorbs all the heat from the cabin. So what type of heat is absorbed? Latent heat. Latent heat is absorbed. So when any substance, refrigerant, absorbs latent heat, there will be change of phase. So liquid will become vapor. That is 1 to 2 process. Okay. Next. So what is the condition at point number 2? The point number 2, the condition is at again low pressure, low temperature, but it is not liquid refrigerant. Now it is vapor refrigerant because it has absorbed latent heat. Okay. Now see here I have written low pressure vapor ammonia, and this is ammonia. So liquid, low pressure, low temperature vapor refrigerant enters inside the absorber. In the absorber there is a water solution, and that water solution will be mixed with this vapor refrigerant, and the mixture of vapor and liquid solution will pump to the generator with the help of pump. Okay, so when you are pumping the liquid and vapor solution, it will become strong ammonia solution. Why it will become strong ammonia solution? Because this vapor is mixed with water, and you can pump easily. Okay, so that is a word we are using, strong ammonia solution. The next is in the generator, our aim is to separate this water and liquid refrigerant again. I don't want liquid refrigerant in the condenser. Okay, it should be in vapor refrigerant, and it should not be mixed with liquid. So water has to go down, again back to the observer. Only refrigerant has to come this side. And in the generator, that is for that reason they are using some heating coil. Keep in mind, heating coil, they will be using electric heating coil. So this heating coil increase the temperature of this liquid and vapor, and it will become superheated condition, superheated vapor. So liquid, due to density, the liquids will get and settle down, because density of water is 1000, density of the vapor will be less. So vapor will go on the top side, and the refrigerant, that is liquid, okay, that is water solution, will get separated. All the liquid will be coming down, and it will come and collect in the absorber. Okay, and it will be help for the next cycle. So what is the condition at point number 3? Okay, here I will take it as point number 3. So entire process I will call it as one process: absorber, pumping, and everything. So at point number 3, the vapor is in the refrigerant is in vapor state. because the vapor and liquid had got separated. And here, due to heating, the temperature increases and it will become high temperature. Initially at point number 2, it was at low temperature. So because of heating coil, the temperature increases. So high temperature vapor refrigerant. And the pressure also increases. We can ask a question, why the pressure is increasing? Because you are using an external device for pumping. Pump increases the pressure energy of the fluid, pressure energy of the substance. So here it will become high pressure. So high pressure, high temperature, vapor refrigerant. And dear students, high pressure is nothing but what? Compared to this, at point number 1, for example, at point number 1, 1 bar pressure is there. At point number 3, it will be 5 bar pressure. That is the meaning. Okay, that is what meaning of low pressure and high pressure. And here the temperature at point number 1, if it is minus 10 degrees Celsius, here high temperature, it becomes maybe 30 degrees Celsius or 50 degrees Celsius, like that. Okay. So at point number 3, what is the condition of the refrigerant ammonia now? It is in vapor state, vapor ammonia. Anyway, you have written here. And it is at high temperature and high pressure. So this high pressure, high temperature vapor refrigerant enters inside the condenser, and as the name indicates, condenser rejects heat. So what type of heat is rejected? Latent heat. Why latent heat is rejected means this vapor refrigerant is converted into liquid here, as you can see here, liquid refrigerant. So when there is a change of phase from vapor to liquid, obviously latent heat will be rejected. So when the latent heat is rejected, now we are getting at liquid solution. And you observe the pressure. Pressure is also high pressure. High pressure in, I think, for example, input is 5 bar and output is also 5 bar. And here is the temperature is 30 degrees Celsius. At the outlet is also 30 degrees Celsius. So during 3 to 4, I will take it as 3 to 4. So during 3 to 4, it is constant pressure and constant temperature process. Okay, let me write here. So 1 to 2 is here. 1 to 2 is constant pressure and constant temperature, but liquid is converted into vapor refrigerant. During 2 to 3, so low pressure will be converted into high pressure, low temperature refrigerant will be converted to high temperature refrigerant, but the vapor state will be remain same as vapor. There is no change in phase condition. Okay. And 3 to 4 in the condenser, 3 to 4, here is a point 3, here is a point 4. So 3 to 4, there will be change of phase from vapor to liquid because heat is rejected, and there is no change in pressure. Again, it is constant pressure and constant temperature. And last process is 4 to 1, that is expansion valve. Here is the expansion valve, or you can represent like this also. This is a symbol which is used for expansion valve. So here expansion valve, what it does, it will do is, as the name indicates, expansion. When any substance or the refrigerant undergoes expansion process, there is a pressure decreases and as well as temperature decreases. So this high pressure and high temperature, high pressure and high temperature liquid refrigerant, when it undergoes expansion, it will become low pressure, low temperature, and it comes to liquid refrigerant. Again, it recycle, same, it completes the one, it undergoes one more cycle. So this is what the working of an vapor absorption refrigeration system. So point number 4 to 1, the process 4 to 1, let me write here. In the process 4 to 1, the high pressure refrigerant will become low pressure, high temperature refrigerant will become low temperature, but there is no change in the phase of the condition. It will be in liquid state. Again, it will be in liquid state. There is no change. But here also there is no change. But in the 1 to 2 process, there is a change. Okay. So 1 to 2 is, what is the name of the 1 to 2 process? That is in the evaporator. Okay, evaporator is 1 to 2 process. Let me take different color chalk piece. So 2 to 3 is this absorber, pump, and generator. That is 2 to 3. And 3 to 4 is 3 to 4. That is condenser. 3 to 4, that is condenser. Here is a condenser. That is point number 3. Point number 4. 3 to 4 is condenser. And the last one is again, that is expansion valve. Here is a expansion valve. That is expansion. Okay, in the next video lectures, we will understand the major and the important differences between this VCR and VAR. Okay, so thank you, and we will meet in the next class.